board. So now whatever you say at this point now is documented. So be careful. Kidding. And just to let you know, we do plan to post this on the STEM Blackboard page. And the CETL group is going to post it on their webpage as well on their Blackboard. So there's going to be multiple opportunities for you guys to go back through and look through this stuff again. All right, so I think the first thing I wanted to show you guys is if you've never used MATLAB before, I just want to show you guys how to access a script. All right, so the first thing you would do is if you've never logged into MATLAB before, what you would have to do is you'd have to click on New, and then you'd have to do Script. All right, and what that'll do is that'll bring you up a new tab. When you run it, it'll ask you to save it. Okay, so and what I always do is I always start by putting these commands in. I always start with CLC. And what CLC does is it clears the entire screen. All right. I'm just going to go ahead and make notations here. Whenever I have a percent is basically just going to be a note. It's not going to be included in the code. Okay. So CLC clears the command window, or I guess the output window. Then also percent is for comments. All right. What I'll do is I'll also save this file and I'll email it to everybody when I'm done. Okay, so don't feel obligated to write every single thing down unless you're that type of person, which is me too. So, all right. I'm just going to start with some basic stuff. If you ever do this, SYMS, okay, Sims declares a variable as a symbolic variable. So I always just go ahead, any variable that I ever create, I make it a Sims variable. So I just say Sims X, and what that does is it makes X a symbolic variable.
Is there a difference between a symbolic variable and a regular variable?
Yeah, the symbolic variables allow you to be able to do commands like factoring, graphing, all sorts of stuff like that without defining a vector. All right.
Oh,
if
okay.
you want to define it as a vector, then you can certainly do those things, but this makes it a little bit easier.
Oh, okay.
All right. Now I'm just going to type in something really basic for you guys just to show you how the execution works. So let's say for some reason I don't have the lattice method available to me, and I want to figure out what 1 + 2 is. All right. What you would have to do is you would have to go over to this editor, and you would have to run it. Okay. So I'm going to run this, and I'm just going to click on the green arrow. It's going to ask me to save it. Okay. So I'm going to save this as, I'm just going to save it as MATLAB 3, MATLAB1, whatever you want to call it. It's probably going to tell me it exists. I'm going to replace it. All right, I have to close that real quick. Sorry. I'm going to run it. I'm going to name it that again. Save it. Yes, I want to replace. And what you'll notice down here is that the answer is 3. Shocking, right? All right. So that's how you get some input and output of MATLAB. If you use a semicolon, all right, what a semicolon will do is it'll execute the command, but it'll suppress it so that it does not output in the command window. Okay, so semicolon, I'm just going to make a note of this. Semicolon is going to suppress this line of output. All right, so I'm going to run it again, and what you'll notice is that nothing came out. Okay, it actually went through, it did compute 1 + 2, but it didn't actually print it to the screen. All right, there's a lot of times in MATLAB that you want it to run commands, but you don't want it to execute those and show them to everybody, all right, because it's just not necessary for the output so far. All right, another command that I always start out with is I always like to clear all. And what that'll do is if there's any variable or any data stored in any variable, it'll get rid of those variables, or it'll get rid of all that stuff. MATLAB is very smart. It likes to save things from the previous iterations of when you ran it. So if you clear all, this basically eliminates former data stored in a variable.
Chris?
Yes.
I just wanted to highlight that when you also use the suppressor, it won't then the operation is highlighted if it's outputted. If it's not outputted, the operation isn't highlighted. So that's another way to know whether you
Gotcha.
put a semicolon or not.
Oh, thank you. Yeah. That's right. Thanks, Lisa. Appreciate it.
Now say that again, Lisa.
If you, so if you take the semicolon off that command line, if you delete it, you'll notice that the operator is highlighted with a yellow block.
I
That
see.
means you're outputting it to the screen. If you add the semicolon, then it's no longer highlighted and it indicates that it won't be outputted to the screen.
Thank you. That I understand now.
They're both like work together.
I did not know that, by the way, so thank you.
I'm a visual, so I always look for that.
Nice. I learned on Pascal, and Pascal never did any highlighting or anything like that.
Well, in fact, that's the first language I ever learned on was Pascal also.
Oh boy, good stuff.
Right. It was. Then they got rid of it, of course.
Yeah, it's true. All right. One other command that's probably going to be helpful to everybody is ANS. All right. If you use ANS is the last, it basically is the result of the last executed command. Okay, so this is the last command executed. So if I run ants, it should be 3, right? Because 1 plus 2 is 3. All right, and then answer is stored, or 3 is stored in answer. So if I run it, there it goes. Answer is equal to 3. That could be helpful if you don't want to type out a whole command line, especially if you have something extremely long. All right. So these are just some very basic commands that I just wanted to show you guys before we start doing some of the exercises in coding. So any questions so far about any of those that I can answer for anybody?
Just making sure that you highlight that ANS is always rewritten every time you run it.
Correct. Right. Yeah. So every time you execute it, like if I did ants again, it would still be 3 and 3, and it would just be highlighted each time. All right. It says it's not recommended. It's never crashed on me, honestly. So.
Yeah, I've never used it before.
Oh, okay. I use it a lot of times when I'm doing like a long command and I want to do a substitution or something like that. And I'll show you guys that in a few minutes. All right. So some of these exercises, I wanted to show you guys just some of the basic evaluation stuff. And this is more for you guys just to get familiar with some of the syntax. All right. So I'm going to get rid of this guy. All right, so the first one that we have is just to execute a fairly simplistic evaluation. So let me show you guys that. So it's 3 squared. All right, so just like the calculator, if you want to raise something to an exponent, you just use the caret. So 3 squared minus 4 plus 17. Okay, just like you guys would in the basic calculator. And then quantity 3. Now, MATLAB's a little bit dumb when it comes to multiplication, and I'll show you this. So 3 times 2. We know in real life that this would just do 3 times 2, all right, plus 16. All right, but guess what happens when I try to run this? It says something's wrong, okay? So whenever you get the red message of death, the good thing is it'll tell you exactly where the error is, okay? So notice right here, it says line 19, column 6. So I go to line 19, and if I were to count over 16 characters, what I would have to do is I'd have to put the multiplication symbol in there. All right, so MATLAB unfortunately doesn't assume multiplication. You have to specify it. All right.
Which is like Excel, just so people are familiar.
Absolutely right.
Not like TI-83s.
No, TI-83 is very kind to us. It's very forgiving. All right, and then it goes through, it computes it as just 1. All right. So just a basic idea of how to execute a command, all right? Even with some of our trigonometric functions as well as transcendentals, okay? I sent you guys that list of basic commands, okay, as a quick reference sheet. That could be helpful so that way you guys don't have to memorize everything. All right, eventually just by doing it, you probably will, all right? So we have sine cubed of pi halves, okay? So I'm going to say sine, actually parenthesis, sine of pi over 2 cubed. Okay, so we just have to think of it like the TI, all right, plus e squared. So in MATLAB, you use exp, all right, and then finally we have this log base 3 of 51. Okay, so we have to use the change of base formula. So we're going to do log 51 divide log 3.
Does it matter if you use log or natural log here?
Actually, in MATLAB, log
Log.
represents natural log.
Yeah,
Yeah.
Oh,
So,
okay.
so
yeah.
yeah. So and we know common log is what we usually have from the calculator, but it's just the way MATLAB's built. Okay.
And you might want to mention what help is, because when you are typing and you type in a command like log and that little help comes up, you can click on that and it'll help you figure that out if you're not
Excellent.
sure. I use help all the time. So you put the open parentheses, a command, open parentheses, and then help comes up.
Yep.
That's
So
the
if
yellow
you leave it
box.
right there, yeah, there's the help. It'll tell you the formulas, and then there's even more help under it if you're not sure what to do with it. Okay, so that's pretty cool. So it was log 51 over log 3.
And that's natural log, correct? For log base 10, you have to put log 10 in, if I remember. Is that correct?
That's right. Yeah. So I think it actually is log 10 if you want to use that. So log is actually equal to ln. We'll keep that in mind. All right. So I'll just go ahead and execute this, and we'll get some crazy number. All right. Doesn't really have any significance, but the point was just to show you all how to execute that. Okay. One final example. I think we have an arc function in there. So we have ln of 1. Okay. So our last one, we have log of 1. Since ln is log. Okay.
Can I ask a question? Can we
Yeah,
stop
sure.
just a second?
Yeah, Lynn.
You have log 51 divided by log 3. Does that need to be in parentheses? Because,
Not
mean,
by the order of operations.
MATLAB follow order of operations and
Yeah.
noted the division first?
Correct. So what it'll do is it'll execute log 51. It'll compute that. Then it'll compute log 3.
Okay, I just wanted to make sure if we needed to put parentheses around the log 51 divided by log 3.
Nope, all good. In
Okay.
fact, I'll just do it anyway, just to show you. So if I were to do this, we still should get, hold on, let me cut that real quick. We still should get, oh, we won't get anything because it's suppressed. That 4.81, whatever it was,
Okay.
same thing. So you could do it with or without.
Just
Okay.
double checking because, you know, I would assume that MATLAB would be smart enough to follow the order of operations. But
Right.
just to be sure.
Yeah, I usually tell students that parentheses are free, so use them a lot.
That's a
Okay.
good point.
Yeah, that's what I tell them too, is there's no penalty for parentheses.
True.
Okay, that's
Not
good to
sure,
know.
just use them.
So we're going to have log 1 plus arc sine of 1. So arc sine is a sine of 1 minus pi over 2. All right. And then I'm going to go ahead and execute that. I'm going to suppress this real quick. So that way we don't get 2 outputs at a time. And it gives us 0. Okay. All right. So those are just, the whole point of that was just to get you guys familiar with just some of the commands, as well as some of the transcendental stuff, especially for those you guys that are teaching which is everybody's teaching calculus or higher. So we probably need those. Okay. So any questions about basic input, numerical evaluation I can answer before we go on?
Yeah, I got a quick question for you.
Yeah, DP.
And this is maybe just something that I like to do. Is there any way to actually make these things like 3 squared actually look like 3 to the power 2?
I don't know how to make it into.
No, the
Yeah, I
font
don't
is
think-
terrible in
Yeah,
MATLAB.
Okay.
I don't think I know how to make it into a symbolic sort of
They
thing.
don't
like-
have superscript or subscript.
Yeah.
Okay.
So we're kind of
Because I know, like,
stuck with it.
In Mathematica, there's like short code. You just do like control caret and it puts a little power up there, stuff like that.
Yeah.
You can actually use a power function. It's power, then you put what you want, and then a comma, and then the power. But that seems like
probably would look
overkill.
even worse. Okay.
Good question. Any other questions, guys?
I have a question. Can
Yes,
you hear me? So the trig functions, they will follow by the radian, not degree, right?
Absolutely right. Thank
But
you.
they
thank you,
do
thank you.
have degree if you put a D on the end, sine D.
Oh, okay.
Yeah.
Could you show example, please?
Oh, sure. So let me make a note.
Sine 30. Let's see sine 30.
So let's just do, for example, sine of 530, right? And then Lisa, what is it? 530D?
No, you put the D after sine, so
Got it.
sine D,
Oh,
like
I
that.
see.
As far as I remember.
Okay.
Yeah, that's correct. So
Thanks.
it seems to be 530 degrees when you do that.
Right.
Gotcha.
Unlike Excel, which you can't
this-
do
Okay.
degrees, you can do degrees and radians with sine D.
There you
Okay.
go.
All right. Thank you.
Cool. Thank you.
And
I didn't
So
know
all
that.
you can do that with any trig function, a, sine, any of those.
Oh, cool.
Okay.
Nice. So this makes, oh, sorry. Let's say recognizes.
The angle is a degree.
Sorry, I'm terrible at typing. My hands are
Whenever
big
people,
and this
when people
stupid.
watch me, I'm always misspelling.
Yeah, I know. When people aren't
I was
watching
going to
you.
mention up at the top here, you wrote clears output.
Oh, thank you.
Yeah.
Line one.
Output.
Meow.
I
All right,
have a
there we go.
question about those commands too, Chris. CLC just clear the output window,
Correct. Right.
but
So-
for the clear, like CLEAR, clear, like clear all the data in the storage.
Right. So you're right.
Right. The variables. So if you look in your workspace, that means
Okay.
it clears all the variables that are in your workspace
Okay.
in addition to the command window.
Okay. So
And
So you can't rewrite a variable.
okay. So what the difference if we put all or without all after clear?
I don't know if it matters.
It doesn't matter. It works the same way.
Yeah,
I
it looks
think-
like it.
I think it's just a little nuance.
I think you're right because I just did it, Superwan, and it looks like in the command window, everything's clear.
Okay.
So
All right. good.
I always
Thank
just
you.
knew clear all.
Chris,
But
you
They
have
have
everything
commands.
suppressed.
They have commands like that in MATLAB all the time that you can sometimes put on or off and it doesn't
Well,
matter. and
I'm
you don't
sorry.
I don't understand.
Well, one
Okay, great. Thank you.
Sure, sure, sure. Okay, any other questions, guys? All good questions, thank you. Okay, so I want to show you guys how to utilize MATLAB to be able to do some of the algebraic operations. All right, anytime you want to do an algebraic operation with a computer algebra system in MATLAB, you have to define that variable as sims, okay? So the first one I have is just to evaluate a polynomial expression, all right? So let me show you guys how to do that. So we are going to, I'm first going to define, so I'm going to say subs, all right, and 3 times x squared plus 4x plus 5. If I keep looking to my left or your right, whichever it is, I have the problems on my other computer, so sorry if I keep looking over. I'm not distracted, I'm just actually putting everything in. So I'm going to substitute into this expression. The old variable is x, and the new variable is -2.
Ah.
And I'm
That's
going to
interesting.
execute that. And there we go. All right, nice and easy. If you now let me show you what happens without the sims. If I forget that, oh, I don't know what I did. I just moved it. All right, so let me get rid of this real quickly.
You know, you just put a % sign in front of it.
Yeah. Oh, thanks, Bill. Sorry. Notice if I don't have sims, it
Yeah.
gives me an error, right? So you have to have sims, otherwise it's just gonna not like you. Okay. So that's how you can do some evaluation, nice and easy with this subs command. All right. The next one we have.
Substitution, right? That's what that means. It's you're substituting x for -2.
Correct. Right. So this means that I'm plugging -2 in for x in the expression. Okay. So basically the form is you have the expression that you're substituting into, the variable that you're replacing for, and then the value or another variable. Like for instance, if I really wanted to, I could say y plus 2. Oh, and I have to do a sims for y, I think. Otherwise, it's not going to like me.
And it just holds on to it with that substitution of those alpha characters in
Oh.
Yep.
Okay.
I'll show you later that you can simplify this expression as well. So you can plug in whatever you
Wait a
want, which is really nice, especially if you're trying to do like a for loop and you want to try to get a number of expressions out of it. So, but that'll be next time when I show you guys looping, etc. All All right.
So it's just saying substitute the variable x in whatever the thing is the next thing to put in.
That's exactly right. Yep.
Okay.
So if I wanted to put y square plus 3, whatever it is, I'll execute it. There you go.
Later, Karen. Do it later. How about after this?
So the idea is that it would be symbolic and not numeric, and then you couldn't do that if you put a matrix in at this point, right?
If you did put a matrix in there, it would actually substitute for every value in the matrix.
Okay, that's what I was wondering.
Mhm.
Okay.
Yeah.
Okay.
So if you had a matrix of polynomials or expressions, you could very easily evaluate it that way.
Oh, so you could put a matrix in for the equation that you want to have substituted multiple times.
Yeah. Like, for
Okay.
example, we could just do x and then 2x. Well, we would have to define the matrix first. So anyway, let me type that back and then we'll move on. So 3 times x squared, was it plus 4x plus 5? There we go. Okay. All right. Another thing that we might want to do is we might want to do some algebraic simplification. Okay. So I have an simplify. All right. Now I have x, y, and z. So first of all, I have to define z as a symbolic variable. So I'm going to simplify this expression. Okay, so it's 2x squared. So 2 times x squared times y squared times z. We'll close that out. Times another parenthesis, -3 times x cubed, y cubed, z cubed times y cubed. Oh, forgot the 3. Close that. And then we're going to divide that by 12x, so 12 parenthesis 12 times x times y to the 4th times z to the 20th, right? Okay. So did I get all that? We'll find out, right?
Now, is that simplifiable? That's the real question.
It is simplifiable, but let's see. All right, so I'm going to execute this.
Oh, wow. Okay.
All right, and there we go.
Negative
It
x
just-
to the 4th y over 2z16. Yep.
Nice. Oh, you did it, Lynn?
Yeah, I had a few minutes to kill, and I figured that I would calm myself with
Oh,
doing
you're the best. Nice. So
pathetic.
did you do it faster than I typed it, though?
Yeah, the typing. takes-
Probably.
That's the worst part of it, is the typing. All right, but that's pretty cool, right, guys? Because you can
Uh-oh.
simplify these expressions, and we can show our students how to do that so they can check their work. And that's one of the most beneficial things I think about this. Okay, so this just simplifies algebraically. I'll do one that like a rational expression. So if I had something like I'll just do an easy one: x squared minus 1 divided by x plus 1. That should just be x plus 1 or x minus 1, right, guys? There it is. Ooh.
Open, close, open, close.
Very cool.
So all that stuff we learned in Algebra 2, completely worthless, right?
Yeah, you just use this now instead.
As long
Exactly.
as you know how to type.
That's true. Absolutely. So
Well, and you have to understand the expression and how to enter it and all that good stuff too. So
So it was okay to simplify the z, even though the z wasn't defined as a sims?
I went back up and I typed it in. as a
Oh, okay.
symbolic
I
variable.
missed that. Sorry.
No, that's okay. Yeah, I'm sneaky like that. Okay. All right. If you want to factor a polynomial. Okay.
Oh,
you
that's
can do
why
that.
I got the angry red letters. I was like, uh-oh.
Oh, okay.
I was like, what's going on?
All right. So give me a sec while I type in this polynomial. 2 times x to the 4th plus 5x cubed. And if I miss a multiplication symbol, somebody yell at me, so that way I don't get the red message of death. So 5 times x squared.
And MATLAB doesn't Mathematica have like a palette versus MATLAB doesn't have that?
It does,
like a
right,
math-
right. Okay. All right. Now this is going to be a little bit different than what you would expect. All right, but it is going to give you the solution. All right, so I'm going to run it. And what MATLAB does is it shows you what the factors are as a vector. Okay, so
Here come the
2x
vectors.
plus 3 is one factor. X
Right.
plus 2, x plus 2, x plus 1. All right. So it will show you all of those. All right. I'm going to show you guys next time how to access elements, but if you wanted to, you could assign this to a variable, let's say y. And then if you wanted to access the first one, you could just say y1. And what that would do is that would pick out the first factor in the array called y. All right, I'll run that really quickly just to show you. All right, so that's one way that you can do this. All right, you could say y1 times y2. And I'll show this to you guys on the next one, times y3 times y4. Of course, that you'd have to know that there were 4 factors from that, but that's okay. So I'm going to run that.
Will it give you imaginary factors?
It will not.
Yes.
It
It
will
won't?
if you tell it. Yeah.
Oh,
So
I
like
was
for
gonna say-
instance,
It has I in MATLAB.
it does. Right. So I'm going to keep this one. I'm going to suppress it. I'll suppress these both. I'll do one really quickly that's complex. So let's say factor x squared plus 1. Right. Unfortunately, it doesn't recognize it as complex. All right. I think you have to define the variable x as complex, and then it'll give you the complex factors.
Oh,
However,
complex factoring. Yeah, that seems like a lot.
This
I was
is
thinking complex roots. Yeah,
check this
I'm
out, man.
thinking it would solve for complex roots,
You
but
have
not
2 equals.
factors.
Is that on purpose?
Yes.
So if and I haven't showed you this yet, but if you go to solve, check this out.
Equal means the quantifier versus the assignment operator.
Yes.
Yeah.
And Lynn, what you notice is it gives you negative I and positive I, right? So
Awesome.
it'll give you complex solutions, but not complex
Right.
factoring.
Okay.
Okay. So
So
I'm
you
going to
could
make some
graph
notes really quickly.
Yeah, that's interesting. I haven't really played with that. I do a lot of programming in MATLAB, but I haven't really played with the symbology stuff much.
Yeah.
Like algebra.
Yeah. Well, I do a lot of linear algebra in it.
Yeah.
Yeah.
You know, line inverts, you know, upper triangular, lower triangular, that kind of thing. Nums, all of that. But
You lost your. No, you didn't. Never mind. Your screen went over.
Oh, sorry about that. Yeah. Okay. Any questions about
Okay.
factoring or simplifying so far, everybody?
Simplify.
Good
this is
stuff.
pretty cool. I know it existed. I just had never played with it.
Yeah. The next question asks us to find all the zeros of the function. That's basically just solving it. So if I just said solve, and I'm going to type this in, so that's 2 times x to the 5th plus 3x to the 4th. If somebody wants to read it off to me, I could probably do it
Well,
quicker.
minus 30x cubed
Uh-huh.
minus 57x squared
Oh, I wonder what this return conditions is.
minus 2x plus 24.
All right. And then we're going to say double equals 0.
Okay.
Double equal makes it, and Lisa said this just a minute ago, but double equal means that you're solving it. You're not setting it equal to 0. It's not assignment. Okay. We're going to say comma x, all right, because that's the variable that we're solving for. All right. I'm going to suppress this one. And what it's going to do is it's going to give the solutions, both real and complex, hopefully. Okay, and here we go. It gives us 5 solutions. Fifth power, fundamental theorem of algebra suggests that there should be 5 solutions. Some of them that are not rational. Okay, so notice that we get this 17 to the 1/2. Paul, you asked me earlier about the symbolic manipulator, and unfortunately, it's not going to tell you the square root. It'll tell you it's the 1/2 power. All right, so, but it does work fairly nicely. All right, so, so again, this will solve another equation.
Okay, let me ask a question about this. If I was to put this into a program somehow, X is certainly going to come out with 5 values. How do you assign that? Is this just in an array? So the way it comes out?
So check this out, Bill. If I said Y is equal to that, right? Then what I get is I get a matrix of solutions. Okay, so I'm going to run it real quick just to show you. Right? So now Y, so see this -3 halves, Bill? That's
Yeah.
Y1. Okay, so if I went
Okay, got
1, that means I'm accessing the first element in array Y right now. All right, so that should give us -3/2, and there it is. Okay.
All right, so it basically builds an array, and the array is however big, and that has all of the roots in it.
Exactly. Very nice. You should teach that, Bill.
Well, it looks like a column matrix, right? A column
That's
vector.
exactly what it is. Yep.
Yep.
All right. Just for the interest of time, I'll show you guys the next one, which is the partial fraction, and then we can move on to data assignment, because this one's actually pretty cool. So last thing, and this could be really helpful in Calc too, doing those partial fractions, as well as, what's the other course that we use it in? Differential equations, right? Where we have to do like those inverse Laplace and the Laplace transforms. That's painful sometimes. So what you can do is you can do this function part frac. I'm going to type in the rational expression. So 2 times x minus 1 divided by x cubed minus 3x squared plus 2x.
Let's see.
All right. Now, the other thing you have to do is you have to, oh, I forgot this parenthesis was the wrong way. Sorry about that, guys. The other thing you have to do with part frac is you have to tell it what variable you're trying to take the partial fraction with respect to. Okay? All right, I'm going to run it. And there it goes. It does the decomposition for us really nicely.
Wow.
Wow.
Yeah. That's really nice, isn't it? Yeah. Remember all those years that we spent doing like those partial fractions in Calc 2 and differential equations and PDEs and all that stuff? Now it's
The
really
A and the B.
yeah.
The A, B, C.
Uh-huh.
Oh, that was fun. I like to teach that in pre-calc.
Absolutely. Sure.
If I
And you
can get
show
to
this-
it.
Yeah, and most of the students that are taking pre-calc, obviously they're going to take Calc or Calc 2, etc. It couldn't hurt just to show them that it's available to them. Okay? All right, so this is a partial.
Comma X.
Okay, let me ask one other question. I mean, this is really cool. Have you tried this using Octave to see if it works there also?
I have not, Bill. I need to do that. For those of you guys that don't know what Octave is very similar to MATLAB. It's a freeware version, though. What's the other one? SimLab or
Lab or something like that.
Yeah, I think Octave's a little bit better. My students have told me that. So the syntax is slightly different in some cases. In the large majority of cases, it's about the same.
Yeah, from my experience with Octave, I've only found one instance where the syntax was different or it didn't do a function the way I expected it to do it.
I found it with looping and other control structures, it's a little bit different. Right. Questions I can answer, or Lisa can answer, about algebraic expressions and stuff like that.
I wanted, Chris, if you go back up to solve for a second.
What was it again?
If you go back up to solve, did you see that you can put in the conditions? Did you ever try that?
I think the conditions are if you only want like something greater than 0 or something like that. I have not tried that.
These
So-
return conditions, I was curious about. So you've never tried it? Okay, I was just
I've
curious.
not. It might, and you might be able to just get to the real part or the complex part.
Yeah,
but
that's what I was wondering.
Yeah.
Hey, Chris,
Yeah,
can I
go
make a
ahead.
suggestion?
Yeah, please.
You were talking about the help feature earlier, but we didn't really go into it. Can we
Yes.
maybe check that out for this
Yeah.
situation?
Yeah, so like in help, what you can do is click up here. Thanks, Paul. You can go to help, and the help is very good, by the way. I think it's I use it almost all the time when I'm confused. And we can just type in solve, and what it'll do is it'll pull up all the different types of solves. There's 22 more. So
Is it on your other screen? Because I don't see it.
Yeah, I
Oh.
don't see it.
I'm so sorry, guys. I have to share this one. Hold on a sec. Let me stop share. I'm going to share screen. There it is. Got it. Can you see it now?
Yes.
Sweet. Okay. So
Yeah, I was just looking at it, trying to figure it out from the examples, but they always have good examples, I think.
yeah, so they have like right here return conditions. So let me see if we can scroll down just to let you know, like here's they'll show you some some examples of syntax. Sometimes it's more complex than necessary, but it'll work. All right. So
Oh, I see. So they're just naming everything, which is what I'm used to doing,
Yeah.
rather than spitting out ants all the time.
Right, and I'm going to eventually do that. I just want people to see like how to just initially do the syntax.
So here's a condition here that's saying int integer.
Where was it, Lisa?
So the condition means the parameter is an integer. So if you're assuming k in the solution is an integer,
Gotcha.
that's what they're specifying.
Okay, thank you. Yeah, I've never played around with that, but that's pretty cool.
Sorry, I was gonna say, I think you might be able to tell it whether it's real or complex, possibly, with that as well.
Yeah,
Returns an empty object. Returns an empty object with a warning.
yeah.
You have to. The issue with MATLAB is you end up putting in like true or false, and there's special terms for all of these conditions.
Yeah, you have to be really careful with those. Yeah.
But I'm curious if you can, like Paul's saying. That's what I was wondering if that meant.
I'm sure there's a way to do it. I've just never done it, honestly. So I can make a note. I can
Scroll down on the left a little bit.
Where scroll down a little bit on the left.
Yeah, I wanted to see if there's anything other than just examples here. Input, output, tips, and algorithms. Okay.
Yeah.
SX, S1, return conditions. Oh, so if you just put in return conditions under the solve, it spits out conditions. It doesn't, I don't think you can specify the conditions. It tells you
Oh, I see. Okay.
how they're solving it under their conditions, like that they're using. That's what it sounds like. So you can just return the conditions they use to get it.
I see. Okay.
Okay, so it isn't as powerful as I thought.
It would have been nice. All right, I'm going to go back. I'm going to share. Okay. Can everybody see the MATLAB interface this time? Okay, cool. All right.
I have just a quick question.
Yeah, Lynn.
For Calc 1. So you created MATLAB or Mathematica problems for the students to do.
Mm-hmm.
Do you usually do that after you've taught and quizzed or examined students on how to do it by hand, and then you give them an assignment after?
Yeah, that's exactly what I do. I might start doing it to where I do them in tandem. So I teach them the analytic method, and then I show them the MATLAB way of doing it simultaneously for reinforcement. But the way I have been doing it is exactly what you said. They take the examination, and then I teach them right after the examination. I teach them the MATLAB code of everything they've done. I've asked students before, and some of them want to do it at the same time. Some of them say it confuses me if I try to do it at the same time. So I don't know. So
okay, I was just curious because I think the idea here is, at least at my level, is to get them used to using it for simple problems, and then you guys can take it to the next level of your class.
Yeah.
You know, just to have them practice. And then eventually I'm going to ask you, if they're doing it and using it, how can I see that they've used it? Is there a way to copy what they've put in?
Yeah, you can publishing. You can publish as a PDF, you can publish as a PowerPoint.
Okay.
Yeah, you can, there's a whole thing about publishing.
Okay.
So they can take the code and they can publish their output and prove to you that they ran it, got this output.
Yeah, and in fact, that's what I do both for the engineering class and the math class that I teach, is that they have to publish their code, and the code evaluates the results, and the results are at the bottom of the published sheet, which is a PDF.
Okay.
Or you could even have them send you the file if you were really ambitious.
I've done that too, and I've actually run it to see if it actually runs on a few people that I wasn't too sure about.
That's actually how I grade all of mine, is that they have to send me a .m and or several .ms, and I just run them all. So. Yeah,
my issue with that is I have my MATLAB will rewrite over, and I don't know which version because they all name it the same. So I've had that problem.
Yeah, you have to be specific. I tell them to use their full initials, and then also like the last 2 digits of their social security number or something like that.
That's a good idea.
Yeah.
Or I'd have to, I guess embedding clear all in each of them maybe would solve that. I don't know.
Yeah. All right. Any other questions before we move on? All right. Good stuff, guys. All right, so the next section is talking about data assignment, and this is basically what Lisa was talking about, where she assigns everything to a variable. And initially, I didn't want to do that. I just wanted to show you guys how to do some of the commands. So,
Are you going to start a new command window?
Yeah, I can do that. In fact, what I'll do is I was just going to keep everything. Like
just
this.
assign variables.
Yeah, and then just move on to new parts. So
Just click on the plus there to get a new window, and you can keep the old one.
yeah, I was just going to make one file and then send it to everybody when I was done.
That makes sense.
Yeah. Okay. So the first one, it says assign the statement hello, my name is blank to a variable a, and then display the message. Okay. So I'm going to say a equals hello world. My name is Paul. All right. Now with text, you have to use these quotes right here. All right. So if you're saving it as a quote or something like that, I'm also going to define a to be a symbolic variable all the way up here.
Oh, really?
Yep.
Really? Okay. Interesting.
That's weird.
You don't have to, but you can. So let me do this. Let me do it without and with.
Okay.
So that
This
way you
whole
guys can see.
symbolic thing is weird because
Yeah,
we just
it'll
use them
work.
as character strings.
And then I'm going to do disp a. Okay.
Yeah.
I'm going to show you guys two different ways to do this. So disp a is going to display it. Okay. So it displays what is stored in variable a. Okay.
And just as for instance, so Lynn, just to bring your point, so 1 equals sign is an assignment operator. See how we use it to say a equals blah, blah, blah. And so double equals is different because you're not
I
assigning.
understand now. I get it. At first I was confused about an operator and the other word you use. I get it.
Yeah, it's weird in MATLAB because you can assign things and it reads right to left, not left to right.
Ooh, okay.
Like up at the top, when you factored, it factors and then assigns it to Y. It starts on the right and then gives it to the left.
Gotcha. Okay.
Okay, so it's
Thank
different
you.
than you would say in an algebra class, Y equals 5, the way we read it. It does it the opposite. Give us 5, put it in Y.
Okay, great. Thanks.
So I'm going to execute this and it'll say, hello, my name is Paul, or hello world, my name is Paul. Eventually it will. There it is. All right. Now, another way to do this, and this is probably going to be more beneficial a little bit later, there's another command, fprintf. All right. So I'm going to say fprintf,
Missing an F.
yeah. And I'm going to say %s, and I'm going to explain what all this means in a minute. So
Yeah, good luck with that.
no, it won't be too difficult. Okay. Comma a. All right. Now this looks like a bunch of heebie-jeebie, right? I'm going to get rid of this display thing too, just for a minute.
And
I'm
you
going
need an F after print. Fprintf.
Yeah.
Yeah, F
Oh, duh.
Angry red letters.
I know. Red letters of death. Oh. All right. So that's another way to output this. So let me explain what all this stuff means. Okay. So first of all, %s means the command is expecting text. Okay. In computer science, we call text string.
Right, strings.
String data type. Okay.
Character strings.
Yes,
String of characters.
String of characters, right. So they don't have numerical value. That's what a string is. All right. That \n, so whenever you do this, \n, that means that the output goes to a new line. Okay, sometimes it's called a carrier. It's just like hitting the enter key.
In the command window,
Yep.
in the output, right? Yeah, a new line.
Yep.
So they don't all mush together.
And then obviously A is the parameter that you're printing. Okay, so the last
And it-
parameter, A, is the parameter assigned to the %s.
Right, and put in that spot.
So right now, see this A? %s is expecting a parameter, and the parameter is going to be A. Does that make sense to everybody, guys, how that works? All right, we're going to be doing this several times. So if you didn't get it this time, I'll show you guys over and over, and you'll probably just get used to it. Let me show you what happens without the \n. So if I just do %s, eventually, notice that these output lines, it didn't hit enter. All right, so if I put it back in with /n, all that's going to do is it's just going to make the arrows go down to the next line. That's all it does. It's more for formatting than anything. Check this out. If I do /n/n/n/n/n a whole bunch of times. Okay, now the arrows are down here because the enter key just hit a few times. Okay, so that's all that does. It's more for formatting, so that way it's not like just all one big line of code. Okay. All right, so any questions about that, guys? I'm going to go ahead and just use one \n. Okay. All right. The other thing that I'd like to show you guys is how to be able to define the variables. So I'm going to set x.
Oh, wait, are
Go
you
ahead.
going to put that in a sentence? Because I think that'll help them understand the %s as a holder.
Right. So what I'm going to do is next, when I do the input, output, and formatting, I'm going to show people how to do the sentences and things like that.
Oh, okay.
Yeah. So, but if I wanted to, I could say this, and I'll erase this, but this is my string, okay, %s. And if I ran it, oh, if I try to run it, sorry guys, I hit the button too many times.
Yeah, I had that same issue earlier.
Okay. So it says, this is my string, hello world, my name is Paul. Okay, so you can put a message. Oh boy, I don't know
That's
what
all
this is.
stuff.
Yeah, get rid of that.
It's gone. But if you want to, you can put a message before it. So my message is, or whatever you want. That might be helpful to say, like, the answer is da 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 da. Okay, so we'll get to that in a little bit. But for right now,
Actually, put a message after the %s also, it turns out.
yeah. So if you wanted to, my name is Paul is my message, I could go ahead and run that. And you could do it that way too. So there's a lot of different ways. You could do it before, after. You just can't do anything in between because A is assigned to be that string.
And just notice that the %, \n goes at the end of the sentence. Otherwise, if you leave it with the s and put stuff after, there'll be a break in your sentence. So that \n, you know, just so you know where the purpose of it is.
Right. Yeah.
But go ahead.
No, that's okay. Sure. All right. So the next one says that I want to define x to be 3 and y to be 6. I want to evaluate xy and x plus y squared. All right. So I'm going to say x equals 3. And I'm going to suppress that because I really don't care what x is. I just care about the answer. Y is going to be equal to 6. And I'm going to suppress that. And then remember we had that subs. Okay. So check this out. I'm going to do subs. And I'm going to do subs again. There's two ways of doing this. I'll do it both ways. So I'm going to do subs. I'm going to substitute for x. Okay, so I'm going to substitute x times y. I'm going to substitute for x.
Squared plus y squared. Oh.
Okay, never mind.
Parentheses, right?
Yeah, or I could just do x times y because I've already assigned it. So this is one way of doing it, sorry. So we could just do xy. I think that was the intent behind this. And we know it's
And
gonna
you're not gonna name that? I would name it like product or something.
Sure. And we could just say like product equals x times y. All right. So now what that does is it makes a new variable called product, and product is equal to x times y. All right.
Now, you might want to tell them too, you see how all the gray highlighting that goes on? We use that when we debug all the time, because if you put your cursor on the X, all the X's get highlighted in the whole command, in the whole program.
Right. So basically,
so if you see that, it's just showing you these are all your X's. They're all named the same thing.
Yep. And then y would do that as well. So yeah, oops, sorry guys. All right. So I'll suppress that. All right. It also says to be able to find x squared plus y squared. So I'm going to say sum of squares is going to be equal to x squared plus y squared. All right. I'm just going to execute that.
Okay, back up in
You
line
accidentally messed up
30.
printf.
Oh, up here, I see it right here.
Yeah, that's what it's complaining about.
Okay, there we go. Okay, let's try that again. Lynn, go ahead and ask me your question.
No, I was just gonna say line 30, you had an issue, and I think that, oh, that wasn't what was wrong.
So line 30. Oh, I have two. Oh, right here. Oh, I got rid of the A. Where did that go? Huh.
I don't know, you hit something and a lot of stuff went away.
Oh boy.
Yeah.
Okay, there we go. Let's try one more time. I just want to get my 45. There we go. All right.
Yeah, I commented out my fprintf so it doesn't print out every time.
I think that's what I meant to do, and I erased stuff in the process.
Yeah, somehow you erased A.
There we go. Okay. When I do when I send everybody the code, I'll unsuppress this stuff for you guys. Okay. All right. So, any questions, guys, I can answer about that? All right. Same thing we can do. Oh, go ahead. I'm sorry.
Actually, I have another question. So, do you have to keep everything in, like you have all of these lines of code? What if I want to just do one problem at a time? Can I erase everything above?
Yep.
Yeah.
And what you can do is you could just make a new window. So right here, there's this plus sign.
Mm-hmm.
You could just click on that and get a new file, a new script.
Yeah, you could take the last 3 lines that he had, put that in a new command window, and then save that as the sum of squares.
So I could just do this, and I could
And
just run it.
I can tell you something about that. I did that yesterday on some problems that I was doing, and I forgot to clear out the workspace. And a lot of stuff from the workspace sort of clobbered this.
Yeah.
So
So
add
I
the
was gonna
clear and
mention that.
CLC at the top.
Yeah, put the clear and the CLC at the top.
yeah.
You don't need to put the word all there, it turns out.
Right.
By
I
the
think
way,
super
if you wanted to
long.
clear out at the bottom, this is cute. After you get done, you can type in clear X, and it'll only erase X.
Oh, cool. That's right. Yeah, you can clear out 1 variable, 2 variables, 3 variables.
Oh, okay.
So that's another way to
And-
do that.
Just as a highlight, so if they've been paying attention to their workspace, they may notice that all the variables show up there. So even if they suppress them, the values are there. If they aren't outputted to the command window, they're still being executed.
Okay. All right. So, does that help out, Lynn?
Yeah, thanks. No, I
Yeah.
was just curious.
They're all really good questions. Okay. Any other questions, guys, before that last one that we're doing? Okay. I'm going to do a Sims P. And then we have this x equals 3p squared. So what is it? 3 times p squared plus 2p plus 1. We'll suppress that. Y is going to be equal to 8p squared minus 4p minus 2. We'll suppress that. And we're going to find Q. So I'm going to make a Sims out of Q as well. And Q is equal to x times y. All right. Now this is where we're going to do this the substitution. So I'm going to do this 2 ways, and I'm going to show you both ways. So I'm going to say subs, and I'm going to do subs again. I'm going to substitute into Q. I'm going to substitute for x, and that value is going to be 2. Then I'm going to substitute for y, and that value is going to be 3. All right, so that's one way of being able to evaluate x, y, given these definitions. All right, so I'm going to execute it.
Q, x2. So evaluate Q if x is 2.
So with it, right. And then
Y is 3.
And then it just takes that answer and it says, okay, well, whatever I got for that, then I'm going to plug for y, I'm going to plug in 3 for that. Okay. Another way to do the exact same thing is to make it a variable. So I'm going to say maybe something like z is going to be equal to subs. I'm going to sub in for q. I'm going to sub x is 3.
Mhm.
And then I'm going to say subs answer, comma y, comma, I'm sorry, it should be a 2 for x.
Yeah, I
Sorry.
was going to say too, yeah.
Sorry.
Wouldn't you just put z in, not answer?
Yep.
Okay.
I think you can do it either way, I think, but I'm not sure about that.
It should be 6.
As
no
long
matter
as
what. Yep.
everything else is suppressed.
Or we could just do subs. I think answer will still give you 6 no matter what. I think you're right.
Yeah, as long as everything else is suppressed. If you had something not suppressed, well, as long as the last thing, I guess. I don't know. I don't like that answer thing.
Yeah.
From
Okay.
somebody that used to do a lot of coding and run coding groups, I would not use the answer there, because that's trying to trace that back. If there's something else that's wrong, it gets impossible.
For
It's not the
debugging, I
script.
think it's hard.
Yeah. So that's how you guys can substitute multivariable expressions. If you had 3 of them, you would do a subs, like in this line, you would do a subs, a subs, a subs. That's called nesting, by the way, for those of you guys.
Or embedded functions.
Embedding or nesting, right, yeah. Nice. Okay.
Okay, forgive me if this is a simple question, Chris. In this subs or line 45, when you did qx2, you're plugging in 2 for the value of x?
Correct.
Into
Yep.
Q.
Okay, so why did you write equations out for x and y if you didn't plug in for p?
Okay. So
Does the answer come out with P?
You
so we're
understand what I'm
sub-
saying?
Yeah,
Yeah.
what happened to P?
Yeah, what happened to P?
Good job, Paul. Good point.
And
So
you gotta
this
ask
answer-
about it. That's an interesting thing.
It should be in terms of P.
Yeah. Okay.
Maybe
what
you
we do
picked up
here?
X from above because you got a lot of X's floating around.
Yeah. Maybe we should clear X first. So sims P, Q, clear X. Run that.
Yeah. So now
Did
it's
the
probably
P's
going to
come?
give us.
No, I got the same thing. No
Yeah.
P's. So do we have any? We don't have any P's prior.
Oh. Let's see what XY is.
Assuming you're going to have to do a
There it
substitution
is.
of y for
Okay.
p equals a number, and then one for x, and then plug them both into q.
Yeah. It was really a bad question that I made up. So.
So that's Q.
Sorry to make that apparent. I feel bad.
No, it's fine. I mean, we want to make sure it's right. Sorry about that.
See what the first line of code, if you put in subs QX2, what does that do?
Just this guy right here.
Yeah, just that part. See if that part, what that part does alone. Like the Z. See what Z would be.
Okay. Oh, I see what you're saying. Let me get rid of that and then I'll.
Yeah, there's the P there. The P is in there.
Yeah.
If you run it with just that line.
Let's see what happens.
So it's the next subs that's the issue. Oh, there's no Y's there in that,
Right.
right? So
Yeah.
did it take,
Right, because it's.
so is it taking the P's and making them 3?
It might be. Boy, I don't know what it's doing, but
That's a little weird.
it is.
Yeah, because it can't make Y3. Or is it back substituting and solving for P? Like it's weird.
Yeah, it is.
Would that be P instead of Q? Like
I don't know what happened in that
I
last
don't
part.
know, from
Ironically, that's 2 times y.
What did we want in the beginning? Let me see.
Yeah, it shouldn't.
Okay, if
Y and
you had plugged in x equal 2 and multiplied it by the equation for y.
I don't know what it did.
Let me see what it was trying to do. To find this
Yeah.
and this, Q is find when X is 2 and Y is 3.
Yeah.
So
So
Hmm.
you can find Q.
So if I don't understand the problem, if X is 2,
Yeah.
are we trying to solve for P?
I think when I made up the problem, I was tired and I
Okay.
meant it to do something else. So
Okay. It's just
So
confusing.
It's a
basically,
bad problem.
definitions of X and Y right now.
yeah. How about I just give everybody credit because the problem was faulty?
Yeah.
Yeah.
I'm sorry about that, guys. So
Okay.
I'll admit this.
Chris, completely understand.
Oh boy.
Yeah, the end goal, I just didn't understand. Okay, so that was my fault because I was supposed to be editing it.
I don't know. I mean, I didn't even know what I made up. So. Okay. All right, guys. But you understand assignment, right? We understand how to access, etc. Okay. All right. So formatting. Oh, go ahead. Sorry.
No, go ahead. You're sorry.
No.
I said I understand how to make the substitution, just not yet with if
Double.
you've got equation with another equation embedded in it. Yeah.
Gotcha. Okay.
Yes. So can we do a double sub of something we already have?
Yeah. So let's say we have X is equal to, let's just say 2 times P plus 1. And let's say Y is equal to P squared for some reason. Let's see. Well, this goes back to the same problem, doesn't it?
Yeah.
Ah,
Yeah.
Well,
how about this?
what if we substitute in P as the last step?
How about this?
Can't we just do that?
Let's let X be equal to 2P plus Q. So it has 2 variables in there, right?
Yep.
Okay.
We're going to do subs. I'll assign it to a variable. Subs. So we're going to substitute into X. We're going to substitute for P.
Q.
We're going to substitute 2.
For P,
Okay.
that works.
And then we're going to substitute for Q. And we're going to substitute 3 in for that.
Okay, now we get it.
That works.
That should
right.
be 7, right, guys? When we
Yeah.
execute that.
Who knows, but that's arithmetic.
Hey, there we go.
Yay,
All right.
math works.
So what that
Okay.
does, I think that was the intent of the problem, Paul, is that if you have a multivariable equation, to be able to substitute for both of those, okay? I don't know if you remember, but about a year ago, you and I were in the office together working on something like that, and we tried like multiple parameters and it didn't work. So now I've figured it out at this point. Okay, cool. All right. So does that make sense to everybody, guys? If you have multivariable equations, how to
And
do
then
that?
again, you could break that up into just sub X equals
Right.
Z and then sub Z Q3.
Yep. Another way to do it is you could say Z equals subs X comma P comma 2, and then do a new line where you can subs Z comma Q comma 3. And that should give you 7 as well. So let's see if it gives us 7 for both of them. It should. There it goes.
Yep, 7 and 7. Lucky numbers.
Yeah.
So that's the method I think you would need to use for the prior problem.
Right. Yeah. Something like that.
Substitute P into both X and Y first, then substitute
Yeah.
them.
Right. Okay. Cool.
Okay. All right.
I'm going to save this really quickly because I know what's going to happen. My computer's going to die and I'm going to lose everything. It's just, it always happens.
My students, I keep telling them every 10 minutes, hit the save button.
Okay.
And then there's always one half hour into it. I lost all my work.
Well, now you know that Control S is very important, right?
Yeah, that's exactly what I told them.
All right. So a little bit earlier, I showed you guys how to do a little bit of formatting, and I want to do that again with you guys. So I'm going to go back up, and remember earlier we evaluated this animal, this sign, blah, 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 blah. All right, so I'm going to assign that to a variable. Okay, so let's say X is going to be equal to this. Okay, and what I want to do is I want to print out, round it to 6 decimal places and print a message. Okay, so I'm going to do an fprintf. Okay, so remember that. I'm going to type in the solution rounded to, what was it, 6 decimal places
Oops.
is, and I'm going to do %.6f, and I'll explain what that means in a moment. \n for the next line. And then I'm going to tell it that I'm expecting X. Okay. Now let me execute it first just to show you that it does work. And then I'll explain what all the syntax is. Right, so I'm going to run it. And there it is to 6 decimal places. Okay. Now, %f. I'm just going to do it without the 0.6 really quickly. All right, if I run it without 0.6, oh, I'm not going to do anything apparently. Sorry, guys. All right, so it actually rounded it to 6 decimal places by default. So,
It does. That is the default. It's 6
oh
Yeah.
boy. All right,
Yeah, 3 is usually the suppressed one,
okay,
or 2 or 1.
gotcha. So let me do 0.2 just to show you what that does. I just picked a bad number with 6. I didn't realize 6 was the default. So notice that 0.2 just rounds it to how many decimal places you wanted it. Okay, so if I wanted 19 for some reason, because I needed to the what?
But do 19? Let's see.
It should.
Oh yeah, because its default is 32 digits of precision.
Yeah.
That's right.
So let me explain what all that means. Okay. In computer coding, F is floating point. Okay, so F equals float, which is basically just a fancy way of saying decimal.
I thought it was formatted.
Is it? I thought F meant floating point and %d was integer. So it might be formatted.
I thought it was formatted too, because if you do 0.0f, you get integers out of it. And that's
Okay.
a very famous code. Everybody
I'll go with
I mean,
that.
it is a floating decimal, I agree, but I think it means formatted, but
Okay.
I don't know.
Thank you. I really always,
Maybe that's the F in front of printf, formatted printing. I don't know. Now I can't remember.
That's what it stands for. It's formatted
Okay.
print. Yes.
thanks guys.
So you were right. I think it's floating.
Okay, that's all right. So formatted and then %.6f means 6 decimal places. Okay. And then again, x is going to be the value that this is referencing. Okay, so if I changed it to something else, remember we had z, it'll print out what z is. Okay, so remember we had that z was, oh, it's string. Never mind, guys. I can't do that.
Huh.
Ignore that.
Yeah, something is going on.
It's because this still has a Q in it.
I think because you didn't do symbol Z up here.
Yeah, it might be that too. Okay. All right. So another thing that we can do is we can do simplification and print that out as a string. Okay. So I'm going to define x to be equal to. Did we do it up here earlier, guys?
You've been asking.
Many X's.
I deleted it.
There's a string.
Yeah. So
The
we're
hello
gonna,
world. We commented out the hello world one,
okay. I thought I put it back. That's okay. So x is 3p squared.
which was A.
Right. So 3p squared plus 2p plus 1.
Hello. Hi.
Y is going to be equal to 8p squared minus 4p. So
Let's see what this is.
4p.
Yeah, I can find out. Why? Somebody's looking.
Oh, here, I see it now.
Okay. So now we're going to expand. I'm going
I'll
to
find
say
out.
z equals expand
Okay.
x times y.
Okay. Great. Bye-bye.
X lowercase x. Okay. All right. So what this does is it go ahead, it multiplies x and y together. And now I want to go ahead and multiply it and then print a message. Okay. Now z should be a string at this point because it has a bunch of characters in it. So I'm going to do f print f. And I'm going to say the product of the polynomials is %s. And then I'm going to get a new line. And then it's expecting z. All right, so let's see what this does. Maybe it'll work. Okay. And I forgot to suppress this.
The product of the polynomials is this.
Yep.
It's interesting that expand makes a string.
Mm-hmm. Yeah.
Is that true? That expand makes a string instead of product? Like.
So if I wanted to, like, let's say, for instance, I did %f, right? It's not a number. It's I think %f expects a number.
Yeah, it expects a matrix.
Right. So %s is just anything, like characters, whatever. So I think it'll work really nicely with that.
So if I put in product instead of expand, would %f work? That's what I was curious.
So let's see. I'll give it a shot.
I'm a little behind. I can't test it.
That's okay. I don't know if product is a built-in command. I think expand is.
Oh, okay. Let me see.
Yeah. All right.
Product.
It says in your sheet, expand X or
Right.
expand is means.
Oh yeah,
to
look. Yeah,
comma
product
multiplication.
isn't a command. So
Yeah.
Z would just be X times Y.
Mhm.
What would that do?
And I could just say, now if I just did this, so check this out. If I just did X, Y,
Yeah, what would that do? That's what I'm doing.
that'll actually just give you the two polynomials, but not multiplied together.
Oh, so they won't symbolically multiply them unless you use expand.
Yep. So what it'll do
Okay.
is it'll just do this.
Okay.
And it'll leave it in the factored form. But if you do expand, then what it'll do is it'll go ahead and put it into the multiplied form. I didn't see
Okay.
the fourth.
Huh.
Oh, there it is. I didn't see the p to the fourth. That's
Okay.
weird. So notice that it doesn't do it how we usually write polynomials.
Descending
In
order.
descending order.
Yeah, just weird.
Yeah,
In
that's a
fact-
weird default.
Yeah, well, whatever. It still does it for us and it does it right. So that's all that
I
matters.
blame all that AI.
Yeah, exactly. So, all right. Something that's really cool is being able to get numbers as well as input from the user. Okay, so
What
check
did
this
I
out.
do?
If I want to try to get a value from the user, so for letter C, it says prompt the user to enter a number and then to find the cube root of that number. Okay, so what I'm going to do is I'm going to say, let's let A be equal to input. And I'm going to say enter a number. Okay. So what this does is it gets a number, or it prompts the user for a number and assigns it
Ooh,
A.
mine is having trouble. Let's see. What did I do?
And then what I'm going to do is I'm going to suppress this because I don't want to see it because I already know what I'm putting in. And then I'm going to say, let's say fprintf, or I'm going to find the cube root. So let's just call it root is equal to A raised to the 1/3 power. That finds the cube root.
Mm.
And then I'm going to do fprintf. Now check this out. The cube root of %f is %.5f, new line, comma A, comma root. All right, so before I execute this, let me explain.
Yeah.
So see this first %f? That's going to reference A. All right, so this first %f goes to A, and A is the number that we got.
Input.
Then the %.5f is going to access the root. And remember, we found root was the cube root of the number A. So basically what you're doing is you're doing two different numbers that you're accessing. Okay, so you're accessing %f for A, and then %.5f accesses root. Okay. All right, so let me run this.
Why do you have 0.5 instead of
0.5 decimals.
for again?
The problem is to round it to 5 decimal places this
Oh,
time.
okay.
That's all.
I got it. Thank you.
Okay. So somebody give me a number. I don't care what it is.
13.
13. All right. So we know 13 isn't a perfect cube. All right. So I'm going to enter the number. The user is going to enter 13. And notice what it says. The cube root of 13 is to 5 decimal places 2.35133. All right. I could do it again. Now check this out. We could use a lot nicer number. Oh. So let's say 729. All right. Now notice, guys, that if you use %f, it automatically makes it into decimals. All right. I'll show you guys a way to be able to get decimals. All right. But we can't assume that the user is going to insert a decimal value or I guess an integer value. Okay.
You could specify though, enter an
You
integer.
could. Right. And then you could do a condition for that, but I'm not worried about that right now. Okay. All right. So does that make sense to everybody, guys, what this command, this fprintf does and how to get the values? Or any
I
questions?
think you should show one that has multiple, like 2 substitutions.
Such as, oh, like 2 numbers?
Oh,
that
wait, this one. You just did that one. Okay, now I got it. A goes in and then root goes in. Okay.
Mhm. Yeah. So what you do is you get the number, you perform an operation, and then you print both the original number as well as the operation.
And you can't do the operation in the fprintf because that would be
I
convenient.
think you can. So
I don't know. I thought I tried
No,
before.
you can't. You're right. You can't. Now you could do it right here. So for instance, if I wanted to do,
Could I? That's what I'm saying. Could I substitute this?
check this out.
That's
I
fine.
think you can actually,
Uh-huh.
I think it actually works as long as it evaluates to a number.
So I'm going to do it right here to find the cube
Yeah,
root.
that's what I was wondering.
Yeah, you can do that.
In compact form.
Yeah, so let's do 729 again, because we know that's 9. And then there it goes. So you
Okay.
can do it in line. The only
Okay.
reason I did it out there was just to reinforce assignment, I think.
Yeah,
So-
I'm just saying if people are reading MATLAB code, a lot of it is really compact, where they reduce the number of lines of code to be the most efficient possible.
yeah.
And that's when it's all confusing and hard to read because you're trying to figure out why there's so much in one line.
Yes. Yeah, it's frustrating sometimes.
Yeah, I never understood that. As a guy that used to run a software group, we had the software style guide that says you don't do those kind of things.
Yeah. Now it's a
Yeah,
free
whereas-
tool.
Whereas I was graded in college, you have more code than you need and no extra lines. And I was like, but I like all the lines.
Yeah. Well, compilers and interpreters have gotten very good, so adding extra lines is not a penalty anymore. It used to be
Oh.
20 years ago, by the way. So
Okay. So now what I'm going to do is I'm going to get a polynomial. Okay. So let's say that I'm going to call that x equals input. Oh, actually not x. Sorry. Let's call it y. So y is going to be input.
Okay.
And I'm going to say enter a polynomial in terms of x. I'll fix it in a sec. Oh, there it goes. Okay. All right. So we're going to, first of all, we're going to get the polynomial from the user. All right. Then we're also going to get a number. Okay. So we're going to say num is going to be equal to input. And we're going to say enter a number to substitute into the polynomial. Okay. All right, so we're getting 2 things, right? We're getting the polynomial and then we're getting the number. Now what we're going to do is we're going to substitute the number into the polynomial. So we're going to say we're going to substitute into y because we called y the input. We're going to, the old one was x because remember it was in terms of x, and then whatever the number is, that's going to be input into the polynomial. And I'm just going to call that a variable eval because we're evaluating it. Okay, so does that make sense what this does, guys? First of all, we're getting a number, or we're getting a polynomial. Then we're getting a number, and then this line substitutes the number into the polynomial at this point. Okay. Finally, what we're going to do is it says
I have a quick
return a
question.
method.
Substitutes.
What's that?
I have a quick question about
Yeah, Bill.
this. Do you have to declare y and num to be symbolic at this point for this to work?
Yeah.
I don't think so because as long as it's a number value as opposed to a polynomial, I think I defined y to be symbolic all the way at the beginning. So I think we're okay with that. The other
I've
ones
done
are, what's that?
3 times now.
Yeah,
I feel like I've defined y as a symbol 3 times now.
that's fine. You can do it as many times as you want. Okay. So now finally, I'm going to print f. And I'm going to print that, let's say I'm going to do %s because I'm going to print out the polynomial evaluated at %f is %f, new line. All right, so we're doing 3 things here. So we're going to print out y, we're going to print out num, and we're going to print out eval. Okay, so check this out. So fprintf, this is the polynomial, which is a string, evaluated at the number, which is num, okay, is going to be whatever the answer is, which is eval. Okay, so does that make sense to everybody, guys? We're getting the polynomial, we're substituting it, and then we're printing the answer. Okay, so let's see if it works. If it doesn't, then you get what you pay for. All right. So enter a number. Oh, this is still the root. Okay, so we're still in the root.
Oh.
Sorry about that. I didn't suppress that. Okay.
Yeah, I have to go up here.
So let's see. So we're going to say 3x squared.
You have to comment it out, not suppress it, right?
Right, yeah.
Because fprintfs run whether you have the suppressor or not.
Yeah, it does. Right. Okay. So that's our polynomial. So I'm inputting 3x squared plus 2x plus 1. Let's just throw 1 into that because we know the answer will be 6. Okay. So this is the old y. So I'm not sure why it did that. That's really weird. I might have to clear the y out right here.
Oh, mine's waiting. Oh, that's what's going on. Mine's waiting for an answer. So it's in a loop.
Okay. All right, I'm going to clear y out. Let's try this again.
45.
I'll just do a really basic
Here we go.
polynomial.
Okay. All right. What's the emergency abort? Do you remember,
I think
Bill?
it's
Do you know what it
Control
is?
C.
It's something like either Control C or Escape, one of those two.
Yeah.
Enter polynomial.
Sorry, guys. All right, so let's try substitute. Oh, it went. Sorry, guys.
Oh,
One more
no,
time.
5x.
For some reason, I don't know why.
Now, let me ask a question about this here. Your input y, the polynomial, you don't have the slash and single s and single in parens at the end of it. So you're literally trying to put a polynomial in there, right?
Correct. Yeah.
Yeah.
I'm not sure why it's doing that. I might have to close the program out and start it again.
Well,
But I
why
did
don't
try to
you
clear it.
take the suppressor off of y there just to see what shows up?
Oh, I see. Couldn't hurt, right?
No, yeah. I mean, when I debug programs, I do a lot of that kind of thing.
Yeah.
Oh, I can't hear.
Sorry about this. I'm not sure why it's doing this. Come on.
Need to flash technical difficulties across the screen.
Yeah.
Sure.
Seriously.
Oh, I was in an infinite loop. It was terrible.
Oh boy.
Okay, so it's picking it up from someplace else.
Yeah.
Why don't you just change the variable from y to, like y1 or something,
Yeah, that's a good idea. All right, hold on.
Or YY.
or yy, whatever. Yeah.
All right, I'm gonna
I'm in
run
a
mine.
loop.
That's what mine kept looping. Oh, it was
There we go.
terrible.
All right.
What's the emergency abort command?
Control C.
Control C? Okay.
Yeah.
Yeah, it had to be either Control C or Escape, one of those two.
Okay. All right, let's try it one more time, and then if it doesn't work, we'll move on. So sorry about that, guys.
Yeah.
Yeah, mine won't prompt me. Oh, I have this up. And now I understand why. Okay, my fault.
So let's say
There's the polynomial.
2x
Okay.
plus 3. All right, let's.
What are we putting in?
Huh.
Okay. Interesting.
2 times x plus 3.
It's doing something.
And then the polynomial you're putting in with p's?
No, I don't know where it's getting a p from, because I just called it y1.
Oh, it's outputting y1 and not prompting you for the polynomial num?
It's prompting me, and it's actually giving me the right answer. It's
Oh.
just printing the wrong polynomial.
Yeah, that's weird.
That is really weird. So
Oh, so it's outputting y1.
yeah, it's outputting the answer, but well, whatever.
Wait, enter number to substitute in the polynomial. Blah blah blah. Oops.
I think if I
missed it.
close it out, it'll probably work.
I'm watching
Just
again.
copy the
Let me
bottom
see.
stuff and open up a new sheet here. Just
Enter
yeah.
polynomial in terms
Yeah.
of x. Why doesn't it prompt you for the number?
It does right here. So it tells me to enter a number.
Oh.
Yeah. All right.
Oh, it echoes Y1 because you took off the suppressor. I see. And then you put in the 3, and it's saying, here's the polynomial. Evaluated at 3 is 7. I can't
right.
see your code.
Sorry. All right. I just copied and pasted it to a new. Let's see if that works. And if it doesn't, then.
Evaluated at 3.
I bet you if I shut it down and then start it up again, it'll probably work. But let me just try one more time. Yep, there it is. All right, well. But if I plug 3 in, the answer will be 7. And there it is. So I think for some reason, MATLAB's confused. Maybe it's Friday and it doesn't want to work. I don't know. All right. I'll fix this up and I'll send it to you guys. I don't know what's going on with it. But. All right.
Why don't you have it spit out eval separately? Like unsuppressed eval, but you're saying that's correct, right?
Yeah. Oh yeah, eval's correct. And the number,
yeah.
It's literally just for some reason. So I don't know. For some reason, it's just spitting out the wrong polynomial.
It's spitting out the right polynomial. It's just rearranging it.
Yeah. Well, the polynomial's in terms of x, not in terms of p. So it's giving us the wrong one, but I don't know why.
Oh.
I'll fix it. Now, I bet you if I shut it down and start it up again.
Where does p come from?
The only p that we have is all the way back up here when we defined y. But
yeah, some substitution going on here that's weird.
Yeah. Paul's in outer space now, apparently. So, nice. All right, I'll move on from this because I don't want to waste your time with whatever MATLAB's doing. But again, I have a very strong suspicion that if I close it and then open it back up again, it'll probably work. It's done this to me before. Okay. Really quickly, I want to show you guys graphing. Okay, so.
Chris,
yeah.
Would you try to clear X also?
Sure. So let me. That couldn't hurt.
Mine says an error about double.
Yeah, let's see.
It's actually a good idea, Super One. We tried everything else to clear. So let's try 2x plus 3.
Oh, whoops.
Sorry.
That was my fault.
Oh, now it didn't do anything.
I see. I'm sorry.
No, don't be sorry. I thought it was a great idea. Oh, well. All right.
Oh.
Huh. Now it's just being really funny.
Yeah, I'm going to type it in independently here.
Okay, see if it works, and I'm going to move on to the other stuff because I want to make sure we at least get through some of the calculus stuff.
Huh. Mine says something about symbolic versus doubles.
Yeah. Well.
I'll work on it.
Okay. I'll fix it up and I'll send it to you guys. I know it works. I just don't know why MATLAB's making it not work. It's bugging me, but okay. Graphing. Graphing's actually really easy. All right. So I'm going to do a sims of x. All right. And check this out. If you'd use this function, easy plot. Let's just do a really basic function. In fact, I probably had one on here. So x sine of x. So I'm just going to do x sine of x first. I'm not going to put any domain restrictions on it. Okay. I'm going to run this. Okay. There's our function. Okay. So this easy plot, it says that easy. What's that?
Oh, okay. But I don't see the graph.
Oh, okay. I see why. I have to share the screen with you. I'm sorry. So hold on one sec. I'm going to have to share this graph. Is that better, Lynn?
There we go.
Yay. All right. So that's what you'll see.
Where does that show up?
It'll actually show up right on top of your code. And also what you could do is you can save it. And this is the cool thing. You can save it. You could just save the graph. And you can save it as a figure or a BMP or a JPG. And you can embed that into a Word file or whatever you want. So that's pretty cool that you can do that.
It opens up
But
a
what
separate
would you
window.
recommend saving it as?
I actually don't save it, but I would, if you were to save it, just a JPG.
Okay,
So,
JPEG.
Yeah,
Okay.
JPEG's probably the best one to save it as. Okay.
Okay.
All right. I'm going to close this
Ah,
and hold on a sec. Sorry, guys. Every time I do this, it's going to go back and forth. So,
That's okay.
all right. Now, if I want to put a domain restriction, I'm going to say comma, and I think it says from -2 pi to pi. So -2 pi, comma 2 pi.
I think I figured it out.
Okay, cool.
It has to do with the input. It doesn't know a string is coming. You have to put %s at the end.
Okay, gotcha. I'll go back and I'll fix it before we and
I
send
think
it to
that's the
everybody.
thing. I think there's something about that indicating there's a string.
Okay, got
I
it.
have to remember this way to do it.
Yeah, I'm making a note right now. Okay. If you want to define the y variable, you type in ylim parenthesis, and then I think it says -1.2 to 2, so -1.2 comma 1.2. And what that'll do is that'll define the y variable when you get the output. All right, so I'm going to run this and show you guys what this looks like, and then I'll switch the screen. Blah, blah, blah. Okay, let me switch. Sorry.
How you put quote s at the end.
All right. So what this does is that it limits the x from -6 to +6, or 6.28 to +6.28, and then 1.2 to -1.2. All right, so that's how you can kind of constrict your graph or only look at a certain part of it. All right. If I want to do some options, let me show you some options that you can do with the graph. All right. So you can put a grid by typing grid on. If you want to label the axes, you can say X label. So X axis, and then Y label, Y axis. You can put a title on it. Okay. And we could go ahead and run that. And I'll switch the screen. So it just takes a minute for it to run, and then, all right, so let me switch the screen real quick. And so notice this time now we have a grid in the background, which might be helpful. And also we've labeled the axes. So now we have a y-axis, we have an x-axis, and then we have a title to the graph, okay? So that could be helpful if you want to put it into a Word document, that we're able to try to do it this way. Okay, so any questions about graphing, at least in two dimensions? Okay.
No, that's great. So I can use MATLAB then if I want to create some kind of graph and put it into a test or a quiz.
Indeed, right. Yeah.
Finally, and will fooplot do that too?
Yes, yeah, fooplot will do it as well. I think fooplot will only save as a PNG file, so it's not as nice.
Gotcha.
JPEGs are a lot nicer to me. Okay.
Right. No. Okay. That's great. Thank you. I'm
Sure.
going to use this now. That's awesome. Because that's one of my issues is anytime I'm trying to put a graph in or change a graph or do something with a graph, I never had the tools to be able to do that.
Gotcha.
So
Oh, cool. Let me show you how to do more than one function on the same graph. Okay. So, sorry. Cumbersome. All right.
it's all right.
So I'm going to do another easy plot. Okay, so, and we had 3 functions this time. So the first function we had was x squared minus 2. And it says that it has to be from -2 pi to +2 pi. I'm just going to cheat. I'm going to copy the code. I'm lazy at this point, sorry. You get what you pay for, right? And then the limits from -3 to +3. So I'm going to copy this. Just go down here. Okay. Now, if I want to put more than one function on the same graph, I'm going to type hold on. Okay. And then I'm going to do another easy plot. And this time it says arctan of x. So I'm going to say a tan of x. Okay. I'm going to do the y-lim again. We have to make sure that the y-limit is consistent each time. And then I'm going to type hold off. Then I'm going to type hold on one more time because I want a third function. Okay, same parameters. And this time I'm going to get a linear function 2x minus 1. All right. So I'm going to run it. And then I'll share the screen once it comes up. This one doesn't have any titles on the graph. It doesn't have any of the other stuff going on. Let me go share the screen real quick. Okay, and there we go. So we get all three of the functions on the same graph. No grid, no title, all that stuff. It does have a title, but it's generic. We can change the title if we want to. We can do all that stuff in the last line. In fact, I'll do it really quickly just to show you that it can be done. Hold on one sec, guys. Sorry, I'm still getting used to toggling back and forth in Zoom quickly, so I'll get
No
there eventually.
problem.
So, so if I wanted to do an axis, so I could do an X label, not A label, X label. In fact, I'll just copy these. Why make it tough? All right, and I'll put the grid on as well. All right, so I'm going to run it one more time. And that should put everything on the same axis. It should give our axes titles. It should do all the good stuff I want it to. Okay, and I'm going to share this. It actually put the other function on there as well. I got to share this with you guys. Sorry. I'm staring at it. I know you guys can't see it. It's not fair. All right.
Oh, wow.
Yeah, so it could be very helpful, especially if I'm teaching Calc 2. One of the things I always do is I use that for the Taylor series to show, like, when the Taylor series gets close to the actual transcendental function or whatever, you could start showing them in different colors. So, or in Calc 1, if you want to do an equation of a tangent line at a specific point, okay. Another thing that's really cool is if you just mouse over, it'll actually tell you the X and the Y value. You could draw on it, I think. So if you want to do like some edits or something like that.
Yeah, the only thing is if you edit it there, you run it, all those edits are lost. But if you want to insert it into your document, you can edit and do all kinds of neat things in MATLAB now.
Yeah.
So you can add a legend too to your program if you wanted to have them identify each of the different graphs separately.
Yeah.
And you can set your axes ranges individually.
Yes. Yeah. Right. Yeah. I just did them all the same just to make it consistent. But yeah, that's a good point. Thanks. Okay. So go back to this one. So any questions, guys, about graphing that I can answer for anybody? Okay. All right. So I think the last stuff is the good stuff, the calculus stuff. All right. And actually, that's the easiest stuff that we're going to look at. Okay. So if I want to find a limit, I'm going to clear all the variables really quickly. I'll just do clear. And let's just do in sims. I know it's already defined, but sims x. So let's say I want to find a limit. Okay. So what I can do is I can do limit. Okay. And then I'm going to type in the function. So in this case, the function is cosine of 1 over x. The variable that I want to evaluate is at x. And then I want to find as x goes to infinity. Okay. All right. So what this will do is this will take the function cos 1 over x. It'll evaluate it as x approaches infinity. Now we know this is going to be 1, right? Because cos of 1 over infinity is cos of 0, which is 1. So we should get a 1 out of this.
I think you better comment out your graph or it'll generate it every time.
Yeah, I was just thinking about that. So, all right. Thank you.
And do you have to use hold off? I've never used hold off.
I think, I can't remember what happens when you don't do it, but I remember not doing it and something bad happened.
Okay.
Okay. So sorry about that, guys. Here's the good stuff. We're going to run it. We're going to get the limit. And we get a limit of 1. I'm going to suppress this thing too. Sorry about that, but that's pretty cool now that we can evaluate a limit, okay, using MATLAB very easily, right? Let me go back and suppress this, whatever it is, this solution up here.
Yeah, I had some kind of
Sorry.
prompt.
Okay. All right. Another example, we want to take the tangent of AX, and where A and B are real numbers. So I'm going to say limit of tan of A times X divided by, oh, let me do this. Let me do C and D instead, because I think we defined A earlier, didn't we, guys?
That was the string.
Yeah, so let me just do C and D, because I know we haven't used C and D yet. Divided by tan of BX as X approaches 0, I think, right? Okay.
Oh.
X as X approaches 0.
Yes.
Symbols, C
Yeah.
and D.
Forgot to define C and D as a symbolic variable. So let me try it again. Okay, and it gives us the answer C over D. Okay, so that's pretty cool, is that even if it's not a numerical solution, we can still evaluate the limit. Okay, one last example, limit of 1 plus A over X. So I'm just going to say C again. So 1 plus C over X raised to the X power, where X goes to infinity. All right. I'm going to run that. And that's just the definition of e to the x, or e to the c in this case, right? Okay. So pretty cool stuff. We can evaluate limits. All right. It's really, really easy to do limits. What I usually do is after the first examination in Calc 1, I'll just show students that they can do this. Okay. For my online class, I don't make my students use it. I should, but they're already buying enough stuff. So any questions about limits, guys? Pretty easy, right?
Pretty cool. That's a little easier than trying to do it by hand or looking it up in a book.
Oh, yeah, absolutely. All right. Derivatives are really easy, too. Check this out, guys. If I want to find the derivative, I use the function diff. I'm going to type in the function. Now, I know the first one says in terms of t, so I'm going to say t to the t, and I'm going to differentiate that with respect to t. Okay, so the way this works is that you type in, it's going to be differential of the function and then the variable. And I'm going to alter that in just a moment, but for right now. Now, you guys know if you want to find the derivative. What?
Do you have to put in oh, you have Sims T on the top. Never mind.
Right, yeah. But you're absolutely right, Lynn. If I didn't do that, it wouldn't work. Good spot.
Okay.
You're talking MATLAB. It's great. All right.
My head's
And then,
gonna explode.
so this is our derivative, right, guys? And we know that we'd have to use a logarithm. We'd have to use logarithmic differentiation to get the derivative of that. Now check this out. This is pretty cool. If I do comma 2, anybody know what that does?
Evaluated it.
Yeah.
It'll find
No.
the second derivative.
That'll be
Oh,
the second derivative?
Yep.
Oh, cool.
So it finds the order. So
Okay.
check this out. I'm going to run it.
Whoa.
Oh, shoot.
You
was about to
get
say
all that
something
other
else.
stuff running.
Oh, there it is. So here's our second derivative.
Yeah, mammoth.
And did you do that by hand, Lynn? And you got the same thing?
yeah, no, I didn't get that far.
I'm just messing with you. If you want to be really fun, check this out. We can do the fifth derivative.
Oh, wow. Let's break it.
The question I get from my students is why?
Exactly. All right. I always tell them for 1/4 point extra credit, they can go home and do it on their own by hand. So yeah, here it
A
is.
quarter of an extra credit point, I'd say forget that.
I joke. So
That's
so
nice.
here's the
though.
derivative. It's a nice, easy one. No big deal. All right. But that's pretty cool now that we can find first, second, third derivatives with this. Okay. So if I wanted to find the second derivative of x tan x, I could do diff of x times tan x with respect to x, second derivative. Okay.
x times tan x.
So I'm going to run that.
Oh, and tan has to be in parentheses, x, x2.
And so here's our second derivative. A lot quicker than we could do it by hand probably, because we'd have to use a product rule. All right, and then we'd have to use a product and a product again, because we get a secant square somewhere in there. Wouldn't be fun. All right.
I don't want to show my students this. They'll use it all the time.
Yeah, I know. Well, a lot of them probably already know about Wolfram Alpha anyway, and that's free. So
Okay.
yeah, but this is pretty cool because you can store it as a variable if you wanted to. All right. If you wanted to find the slope at a specific point, you could do it. So let's say we have a function. Let's say I'm going to diff. I'm going to assign it to a variable. So let's say y. Well, let's not use y because y doesn't like us for some reason. Let's say z is going to be equal to diff of x e to the x plus e to the x plus 3.
X times e of x.
And then what I'm going to do is I'm going to substitute into z. The old variable was x, and then the point was 0, 1. So I'm just going to substitute 0 back into the derivative. Okay. Now what that's going to do, it's going to find the derivative of the function. It stores it in z, and then the next line just takes the derivative, which was z. Instead of x, it's going to plug in 0. Okay. So let me go ahead and run this.
Oh, you just did +3 instead of +3x.
Oh, it should have been 3x. Thanks, Lynn. I'm
That's
sorry.
okay.
No, it's not okay. It's wrong. Okay, thank you. I'm going to run it again. I'm so
No,
sorry.
no problem, because I'm like looking at it going, wait a minute.
Yeah. And so what it does is it gives us what the derivative is.
At the point 0.
At the point 0, 1. All right. If I wanted to, I could find the equation of the tangent line. Okay. In fact, check this out. We might be able to plot them both. So let's do this. Let's do an easy plot.
The derivative of that at the point.
Of x. Let's easy plot this.
2 minutes, Karen.
Okay.
We
Put a
just can't
full-
put z in? Oh, because you're doing easy plot
I'm
and
gonna
not
do
plot
both of
f.
them. Right. I'm going to do.
If I
easy
did plot f, I could put just z in, couldn't I?
But I'm actually plotting them both on the same graph.
Oh, that's a problem. You'd have to do.
Yeah, that would be painful. But with easy plot,
I find plot f to be really difficult.
so
I don't know. You
It
would do
did
it
it.
the same and then just do the hold on.
yeah. So let me share the screen real quick. It did it, but it gave me like some sort of error. I don't know why, but hold on one sec. And not surprisingly, the functions look almost the same because they both have that e to the x shape on them. So, so what it does is it plots both the derivative and the original function on the same graph. So that might be helpful to show your students, especially with respect to linear versus quadratic and all that sort of stuff.
Yeah, like a polynomial that
Yeah.
you could see the derivative would be a line.
Yeah. So pretty cool stuff. All right. So guys, any questions about derivatives that I can answer for anybody? All right. So I'm going to percent all of this stuff. Let me go back. I'm just going to percent everything so we can suppress it. So that way we can get to the really fun stuff, right? The integration. This is the one you don't want to show students because then they're never going to do an integral ever again.
Yeah, I don't need that. I'm not teaching Calc 2.
All right. So this is a really fun integral. And when I say fun, I mean torturous.
Oh, you can just say easy plot z.
So I'm going to integrate. So the function int means integrate. I'm going to integrate expx times sine of x. Okay. All right. So what this does, and I'm going to integrate it with respect to x. Okay. So int, you type in the function, and then you type in the variable.
Okay. Where do you put the limits if you're doing it?
Give me 1 minute, Bill. I'll show you what to do with that. But what you would do is you would just type in comma 0, comma 1 right
Ah,
next to it.
okay, so it's optional then.
Uh-huh. Right. So I'm going to go ahead. By the way, if you try to do this by hand, this is one of those iterated integrals that you would have to solve in terms of the integral. It wouldn't be fun to do this by hand. Let's just say that. Students hate me when I make
Not that
them do
bad.
Yeah, it's not that bad. And then here you go. You get your answer right away from the integral. Okay, pretty cool, right, guys?
Mhm.
Well,
Okay.
the students will love it a lot more. All right. As Bill was suggesting, what if you have limits of integration? Okay, so the last one we have, I want to
Okay.
integrate x to the fourth times the quantity of 1 minus x to the fourth power. And I'm going to divide that by 1 plus x squared. All right. With respect to x, and the limits of integration are 0 and 1. All right. I'm going to execute this. That's really cool. It gives us the precise answer for that.
Huh.
I think to be able to evaluate that, you'd have to use a trig substitution of tangent. It just gets really ugly trying to do that. So for a quarter point extra credit, if somebody wants to do that, go ahead. Don't do it.
22/7 minus pi.
Yeah. Okay, guys. So that's all I got. Whew. And we still got 3 extra minutes, man. Wow.
That's
All right,
pretty good.
So,
Go ahead.
Chris, I was going to say, and I forgot because we were doing that one plot and we couldn't get it to the input statement, but I was going to say back at the FNF, we have some couple of examples that we do in 103 where we do like, we input an angle and then we output the sine, the tangent, and the cosine, just to show like an interaction.
Yeah.
And I can, if I have the file, I can share it with you and you could share it with everyone else. To see how that whole command, that whole program would run and do that. And then we also have one where we convert temperatures, like give us a temperature and you
Yeah.
output it in Kelvin, Celsius, and this,
Very cool.
So those are just examples where you would use that.
Yeah, absolutely. So good stuff. Yeah, if you want to send that to me, that'd be awesome. And then I could just share that with everybody in the group just to give you examples of how to utilize that stuff.
Yeah, and they can run it in practice and you just see how it works.
Sounds like fun.
Yeah.
Hey, Chris.
By the way,
Yeah.
while you were doing this, I got the polynomial thing to work right. There's just
Oh,
something
cool.
weirdness going on with MATLAB there. That's all.
That's what I figured. So, Paul, were you going to say something?
Yeah, just off to the right of your bar there. What are these little orange
That's the
marks?
data type. Oh, the orange marks are breaks, right?
I think it's just comments from MATLAB. So, like right
Where's
here,
my little cursor.
produces a
Oh, I
value
find-
that might be unused. So let's say you get an answer, but it's not logically correct. So the syntax makes it run. I think what MATLAB does is it goes through and it picks up like potential places where it could be stored incorrectly in the microprocessor. I think that's what that is.
Well, they're actually colored also. If it was green, it shows us the executable statements that are actually working correctly.
Right, yeah.
So those are orange. So it's suggesting there's something suspect that you may want to go take a look at.
Exactly, right.
Improvements. It seems like improvements
Yeah.
Yeah.
Now,
Because you
were
guys know,
de-
like, yeah,
for
sometimes you get,
debugging.
exactly, because sometimes you get an output, your syntax is correct, but your logic's incorrect. So I think that's what that it's suggesting. It might be a logic error there. Okay, good question. Thanks, Paul. All right, guys. Any other questions I can answer for anybody or try to answer?
I think this is very good. I learned a
Cool.
few things. That's always good.
This was really cool that we made this happen over the internet. So thank you all. And I know like it's been a bear trying to modernize our classes so that way we can go online with them. So let me know what else I can do to help you all with this. I think the next session is going to be on the 17th of April. So in between there, if you guys have some questions for me, let me know so we can try to make sure we're set for that stuff. Okay, everybody?
Session is going to do what then?
Oh, so what we're going to do is we're going to start doing some data control structures. So we're going to do if statements, looping, a little bit more with stuff like that. So you're welcome.
I am not joining that one. Sorry.
Okay, gotcha.
I've got what I need for my Calc 1 classes.
Exactly.
I will try to integrate some of these into class, maybe not in the fall, but soon.
Yeah.
And have them do just some easy things just to start using it, practice with it, play with it, as long as I'm allowed to have the licenses for the kids.
Yeah. So,
Did anyone resolve that issue with the licenses this semester?
go ahead. Sandy, were you going to say something?
I have no license, but I currently using a laptop from the STEM division. So yeah, hopefully I will get the license.
Yeah, I think we only have like 8 or 9 licenses. So for next year, we need to try to figure out how many licenses we need for the divisional use. Now, there are other licenses on computers like in Aberdeen 223, in the library, in the Learning Center. So, but I don't know who's purchasing those. I don't know how much they cost, etc. So essentially, if you want MATLAB, just email me so I can make sure that you guys get access to it for the fall.
Okay, access to it where? Like on our, like my Surface, my desktop, my classroom?
If it's a computer owned by the college, then they can put it on there.
Okay.
If
Now,
not,
is it per computer or is it per person?
I think it's per person because I have one on my work computer as well as my work Surface.
Yeah, I have the one on both.
Okay, because that's what I would want, and then I would need one in a classroom, you know, depending on where I'm teaching Calc 1, I would need.
Yeah,
And-
the key is to, if we're gonna abandon Mathematica, take that budget money and put it towards MATLAB licenses.
We could just have them both. That would be awesome.
But that's the
Abandoned
idea.
Mathematica. How dare you?
I do like Mathematica, I'm not going to lie.
I mean,
There
limit
are certain things
Mathematica,
that
reduce
does way better than
Mathematica.
this. Some of the inputs just look way better. The answers don't come out as a line.
Yeah.
Right? It does have pi instead of write pi all the time, that sort of stuff.
Yeah.
Well, I think that even for Lynn, she should really return for the session on matrices because that's really the power of MATLAB, is in a matrix, and the application of running the data structures through these symbolic manipulations with thousands of pieces of data.
Yeah.
And that's what Mathematica doesn't have.
Oh, okay. Well, but I
have a question, Chris.
Yeah, Super One.
For this semester, what would you do with the students? Do you still assign students with the MATLAB assignment?
I had almost all of my students do not have a MATLAB license.
Okay.
And it's $100 if they want to buy the one with the symbolic processor in it. So what I'm doing is I'm making them write the code, and then I'm going to run it in my version of MATLAB, but I'm going to grade it very easily. It's only going to be worth 5 points, quite frankly. And then I'm going to send it back to them. But I don't have much I can do with them with that. So the only thing I can do is like what Bill suggested is to use Octave instead.
Yeah.
But that means I have to learn Octave, and it's not too difficult. But with everything else right now,
right,
I don't think I'm inclined to do it.
Yeah, I was going to assign MATLAB, but you know, when school closed, so I just changed my mind back to Mathematica, and they can still download the student license to their home computer. At this point, at least we get the most out of the Mathematica license before we, you know, stop using it.
Right. Yeah,
so that's my plan. I just changed my plan after, you know, last week.
I like it.
Yeah. I don't think anyone's going to hold anyone accountable this semester for the rest of it.
That's
all we can do, right?
Yeah, I'm pushing incompletes today or withdrawals. Like, if you can't handle this, maybe you should think about this.
Okay, what I've done in my classes, all of them, I pushed everybody to get Octave. I've only had 1 or 2 people that have had issues downloading it. In Engineer 103, there is no difference in what we're doing between what's in MATLAB and Octave, except for one minor difference. It just has the way the GUI looks, and that's easy to explain. And so I've been able to run all of the things that we have in 103 through an Octave processor. I'm actually doing the demos in Octave right now from that. So it
But
works.
I think Pamela said that you couldn't do linear algebra through Octave.
No, that's true. Not true. You can do linear algebra. There was one example of a symbolic function that I couldn't find, and it was a really obscure one, and I found a very easy way to get around it.
Oh, good.
So it's, you know, I'm all the linear algebra I'm also doing in Octave. In fact, I was going to suggest for the next session, I'm going to share my crypto code with Chris so he can pass that out, because it's got a lot of these conditional type statements in it.
Oh, cool.
And it's a good example of how that looks.
I have a quick question. If the four-year colleges are requiring MATLAB, why are we not able to get our students to have MATLAB at the two-year college? I mean, is it $100 per year, or is it $100 just once, or what's the deal?
I think it's $100 one time.
Yeah,
Okay.
and they have it for 4 years.
Yes.
But my question, has anyone researched, like we're going to do SolidWorks, if we buy enough, they offer a free student access? Does MATLAB do that sort of thing?
Susan, Pamela, and I are going to sit down in April when we're doing the budget, and we're going to talk about opportunities for students to have access, much like they have Mathematica access. So they can just download a copy. I don't know how much it is, but go ahead, Superwan.
Yeah, sorry, you go ahead. You finished what you
I'm
wanted
done.
to say. Some universities, they have the access, like the student can access, for example, like go to Outnet and then access MATLAB remotely. Like, yeah, I have seen some universities that doing that, but I don't know how much license that we have to buy.
Right.
But that gets student will not download to their home computer. They just access remotely to the college website.
Very cool. I mean, that would be awesome too. So.
Yeah.
Because when go ahead.
I'm done.
I was just gonna say, because if I can't require my students to spend $100 to do like 4 small assignments in Calc 1, that doesn't make sense. So unless we can get some kind of access for them that they don't have to pay that kind of money, unless it's going to be required for those people moving on, but not everybody in my Calc 1 is taking Calc 2 or Calc 3. So I guess that's my question.
They can do it on campus when we have campus ever again.
But Superwan.
Students also can get a 30-day trial license for free for MATLAB. And of course, then at that point, they want you to pay money.
Yeah.
And so you have to be very careful with how you use that opportunity. That's part of the reason I went to Octave, and I've had no real issues with Octave.
I'll have to check it out then.
I know other community colleges that have told me they use Octave exclusively for that reason. Because it's
Yeah. I mean, the differences I'm finding are so minor, and they're real easy workarounds for things.
Yeah.
But I know that the MATLAB experience, or just the Octave, is allowing our students in engineering to get internships.
Yes.
Not Mathematica.
Yeah.
Oh, okay. Well, that's good to know, because
they're doing data crunching.
Octave.
Superwan, did you want to say something? Sorry.
Yeah. For the cost, what the one that we are working on, the cost action form?
Yes.
The new one, if it's approved, so the fee, $20 fee is included. So that should help. I mean that should
offset
convince the college to buy enough license for the student, because student is charged extra money for the course, $20 for Calc 1. So that's right. I remember. Yeah. Maybe when you talk to Pamela and Susan, when you guys discuss about the budget, bring up this issue, so we have the reason to have like bigger license for the students.
Agreed.
We charge them more money.
Agreed.
Yeah. So that's it.
Cool. All right, guys. Anything else before we disband?
No, just thank you very much, Chris,
Yeah.
for doing this. This
Thank
was
you so much.
Yeah,
Ray.
thanks for putting
Thanks,
this
Lisa,
together.
for taking a
Thank
look
you.
through everything and helping me out with
Thank
everything.
you.
So I had a lot of
Oh,
fun.
thank
guys.
you, Chris.
All right, take care, everybody. Be well.
There you go.
You too.
Bye, everybody.
Bye-bye.
Okay, bye-bye.
Bye. Bye-bye.